All right, you're probably wondering, why are we teaching chemistry in biology? Well, biology depends on chemistry. Without it, none of us would be alive. When you eat your food, when you digest your food, those are chemical reactions which break down that food to give you energy. And to get that energy, those are more chemical reactions to turn into ATP energy that you can use. Breathing, oxygen and carbon dioxide, getting oxygen into your blood and getting carbon dioxide out. Those are all chemical reactions. Even the feelings that you are feeling right now, you're like, this is the boringest thing ever. Well, those are influenced by chemicals in your brain. That's chemistry. So anyways, here we go into the world of biochemistry. All right, so here is matter. What is matter? The definition of matter is anything that has mass. Remember, mass is kind of like weight, and it occupies space, so it takes up room. Now, what is mass? So it says anything that has mass. Mass is kind of like weight. It's the amount of matter an object has. Now, here on Earth, weight and mass is the same, but remember, if you ever are an astronaut and you go to the moon, your mass will not change. You will have the same amount of matter in your body. However, your weight will change. Your weight will go way down because weight is the effect of gravity on an object. And since the moon has less gravity than the Earth, you will weigh less on the moon. But you will still contain the same amount of matter. You will still have the same mass. Now here's a question for you. If you had a balloon, one balloon is totally filled up with air, and the other balloon is totally flat. Which balloon is going to weigh more? If you put them both on a scale, which one is going to weigh more? Well, the answer to that question is this balloon right here. Of course it's going to weigh more because this air that it was blown inside of it, it is matter. Those have atoms, oxygen, nitrogen, carbon dioxide. Those are matter. Those have mass. So this balloon is going to weigh more than this empty balloon, which has nothing in it. Okay, so the basic unit of all matter, things that have mass and occupy space, like you're full of matter. You have mass, you weigh something, and you occupy space, obviously. Well, the basic unit is something called an atom. Hopefully you guys have heard that before in middle school or elementary school, whatever. Well, atoms are made of 3 different types of subatomic particles. The first one's called a proton. Protons have a positive charge, and those guys are located within the nucleus. So this guy up here, this atom, the nucleus would be that little red ball in the middle. Those are where the protons are going to be found. Also in the nucleus are these particles called neutrons. Now, neutrons have a neutral or no charge at all, no charge. And they're also located, just like the protons, within the nucleus. Now, another very, very important subatomic particle is the electron. Those guys have a negative charge. And those guys are flying around the nucleus in various levels or electron clouds. So the electrons would be these guys right here, flying around the nucleus. And a little diagram of a helium atom. So here in the nucleus, we have the protons and neutrons. Here are the neutrons, neutral charge. Helium, it's helium because it has 2 protons. Helium always has 2 protons in the nucleus. And to equal it out, it also has 2 electrons flying around the nucleus of the atom. Now I want you to see that helium has 2 protons and 2 electrons. Well, in this first energy level, or this first level of electrons, it can only hold 2. That's all it can hold. So helium is totally happy with its 2 electrons. On the next electron cloud that's going to form outside of that, in some other elements, it can hold 8 electrons. And what you need to know is all elements want to get 8 electrons in their outer shell, or if they're like helium, they only want to have 2 in their outer shell. So they want to have their outer electron shell filled. So with helium, the first electron is filled with 2. But for all the other elements, they want to fill it up to 8. All right, so this is the periodic table of the elements. So these are all the elements found on Earth, either naturally occurring or some have to be made in the lab. So don't worry about this too much because you're not going to need to know pretty much any of this, but I just kind of want to get you a little brief understanding of how this works. Chemistry, you will have to know it, but not so much here in biology. So this is the group 1 right here. All these elements right here, they're atoms, they have 1 electron in their outer shell. So hydrogen up here at the top, and then lithium, they have 1 electron in their outer shell of electron. That's called their valence electrons. Group 2 has 2 electrons in their outer shell. We're going to skip these transition metals because they're not really that important when it comes to biology. In chemistry they will be, but not this year. Group 13 has 3 electrons in their outer shell. 14 has 4, 15 has 5, 16 has 6, 17 has 7. And then you got your noble gases over here. They have a full outer shell of electrons. So helium up here at the top, its outer shell has 2 electrons because the first shell or energy level can only hold 2. And the rest of these guys, from neon all the way down, they have a full outer shell of 8 electrons. So these guys over here in green on the far right, they're the noble gases. They have a full outer shell of electrons, and that makes atoms very happy. It makes them very stable. They don't want to make chemical bonds because they have all the electrons that they want. Now, where these elements occur on the periodic table determines what type of chemical bonds they want to make. So I'm going to make a little drawing of the sodium atom right over here. So first, we're going to go with the nucleus. So the nucleus has the protons and the neutrons in the nucleus of the atom. And then the electrons are flying around the nucleus in these various energy levels. So the first energy level for sodium has 2 electrons. That's all it can hold. 1, 2. So it has a full inner shell of electrons. Its next energy level is full with 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, sodium would be happy because its outer level is full with 8. But sodium is in group 1. It has one more energy level that only has 1 little electron in it. That makes sodium very unhappy. It wants to get rid of that 1 electron. It wants one of these other elements in the periodic table to steal or take that electron from it, because if another element, say like chlorine over here, if it steals its 1 electron, then its next energy level down would be full with 8. That's why sodium and chlorine's over here in group 17, it has 7 electrons in its outer shell. It would love to steal 1 electron because then it would get 8 and it would have a full outer shell. Sodium would also be happy because if it gets rid of that outer shell electron, it would also have a full outer shell of electrons of 8. So that's why we get things like NaCl, which is salt. And that's why sodium and chlorine tend to make chemical bonds, because sodium wants to get rid of 1 electron, so its outer shell will be full, and chlorine wants to gain 1 electron, so its outer shell will also be full. And we're going to go over that here in the next couple slides. We're going to see why elements make chemical bonds in order to make their outer shells complete or full. And now elements and compounds. What is a chemical element? Well, a chemical element is a pure substance. Pure. It consists entirely of only one type of atom. So if you had like a chunk of gold that was 100% just gold atoms, boom, that's an element. So that's gold. If you have pure oxygen, that's an element because it's only oxygen in there. That's it. phosphorus, uranium, all the elements can make a pure substance, a chemical element. Now, what's a compound? Usually things in nature, they're not in their pure form. Almost everything wants to make compounds. For example, this stuff right here that you spread on your French fries, that's sodium chloride or salt. It is one sodium atom bonded to one chlorine atom. Now, something I want you to see here is that the compounds that are made have nothing to do with the elements that make them up. So, for example, like I said, sodium chloride, salt, the stuff you spread on your French fries, it's made of sodium and chlorine. Well, sodium is an explosive metal that will blow up if you put it in water. Kind of a dangerous substance. What's chlorine? Chlorine is a toxic, poisonous gas. It killed thousands and thousands of people during World War I when they used it as a chemical weapon. But when you put those two things together, an explosive metal and a poisonous gas, what do you get? Sodium chloride, totally harmless. Put it on your French fries, put it in your chips, put it wherever you want, and eat it with your food. And basic chemistry. What do the letters and numbers mean in these chemical formulas? Like, this is not really spelled good, but what does H2O mean? Remember, that's water. That is water. The water you drink. H2O, what does that mean? Well, it contains hydrogen. How many hydrogens does it contain? Well, it contains 2 hydrogens, because that's why that little number 2 is there. How many oxygens does it have? It's got 1. How about this guy? You better become familiar with it because we're going to need to know it. C6H12O6. That is glucose. That is a sugar. Well, what makes up glucose? It's got the C because it has carbon atoms in it, and it's got 6 carbon atoms. Well, why does it have the H there? Well, yeah, that H stands for hydrogen. And how many hydrogen atoms does it have in it? In one glucose molecule, it has 12. And it also contains O, or oxygen. How many oxygen atoms does it have? I'll wait for your answer. Hopefully you picked 6, because that is what that 6 is there for, because glucose has 6 carbons, 12 hydrogens, and 6 oxygens. And now chemical bonding. The octet rule, I've kind of gone over it already. Remember, hydrogen and helium, they want to have 2 electrons in their outer shell. But everyone else, they want to get a full outer shell of 8 electrons. So for atoms that only have 7, they want to add 1 electron to give them 8. Now, atoms that have 1, there's no way they're going to add 7 to get 8. But if they can subtract that 1, it won't equal 0 because their next energy level of electrons will be full with 8. So some elements are wanting to get rid of electrons, and other ones want to get them. And that's what's called the octet rule. They're all trying to get 8 electrons, 8 electrons in their outer shell. Now, one way they do this is through ionic bonds. Ionic. It's called ionic bonds because you form things called ions. Ions are charged particles. So remember, atoms, they'll have like helium has 2 protons with a plus charge, and it has 2 electrons, which have a minus charge. Well, 2 and 2 will cancel each other out, and that'll have no charge. But if an atom gains or loses electrons, it will now become an ion. Because if it loses 1 electron, it will now have more protons and it'll get a positive charge. If it gets a positive charge, it'll be called what's called a cation. Cation. If an electron or an atom gains electrons, it'll now have more electrons than it does protons. It'll then have a negative charge with more electrons. Those guys are called anions. So cations are positive because they lose electrons, and elements that gain electrons will become negative and become an anion. All right, so here's chlorine. This is an ion. Chlorine only has 7 electrons in its outer shell, but here you can see it has 2, 4, 6, 8. Chlorine has stolen an electron from some atom. Now, one atom it loves to steal from is sodium. Well, how many electrons does sodium have in its outer shell? Well, sodium only has 1 in its outer shell. So sodium wants to give that electron up to chlorine, and chlorine loves to take it because then it'll fill that outer shell, not with 7, but with 8. And now, sodium has its second level is filled with 8, so sodium would be happy. But since sodium has given up an electron, it now becomes a positive ion because it has 1 more proton than it does electrons because chlorine stole that electron. Well, chlorine, now that it has 1 more electron than it does protons, it has a negative charge. Well, I know you guys have always heard that opposites attract. So this positive sodium will now be attracted to the negative chloride ion, and that's what gives you NaCl, or salt. Salt is formed because of an ionic bond, the transferring or stealing of electrons from one atom to another. And the other main type of chemical bond that we're going to talk about are covalent bonds. And that's not where an atom steals or takes an electron, but this is when 2 or more atoms actually share electrons. So I'll try to say this over here. So like hydrogen, remember this is water here. H2 means there's 2 hydrogens, and you see 2 hydrogens there. O means there's 1 oxygen, there's 1 oxygen. Well, hydrogen has 1 valence electron. Now it wants to be like helium. Helium has 2 valence electrons. It wants to get like that. It wants to get 2. Remember, all other elements want to get 8. But helium and hydrogen, they're happy with just 2. So both of these hydrogen atoms are not happy because they both have just 1 electron. But this oxygen is also not happy because it's got 1, 2, 3, 4, 5, 6. So oxygen wants to add 2 electrons. Because if it does, 6 plus 2 equals 8. And all other atoms want to get 8 electrons. So what happens here, oxygen shares its 1 electron with hydrogen right there. And oxygen shares its other electron with hydrogen. And hydrogen is also sharing its 1 electron with the oxygen. So now, both oxygen atoms think that they have 2 electrons in their outer shell, like helium, so they are happy. Oxygen, on the other hand, which only has 6, but it's sharing these 2 here, sharing those 2, 4, 5, 6, 7, 8. Oxygen also thinks it has 8 electrons in its outer shell. So oxygen is also very happy right now. And that's basically all chemical bonding is about. Try to make the atoms happy by filling their outer shell of electrons. All right. Thank you very much for listening. I know this is kind of confusing, but we'll go over it some more, so I'll talk to you next time.